Okay, and by the way, today is the 7th. Okay, we're going to be given three vectors: u, 1, 2, 3, v, 0, 3, 4, w, 0, 1, 1. U, v, and w. Say. And what we're going to form is a parallelepiped. Here's the base. And what we're going to do is have a top that's, oh boy, something like this. And connect these, something like that. Okay, hopefully it makes some kind of sense here. I can fill these in a little bit better. See it a little bit nicer maybe. All right, something like that. Okay. We want to find the volume of this parallelepiped. The volume is equal to the area of the base times the height. Okay. Take any of the faces as the base, but what we'll do is take V and W as the base. These two down here. Okay, that's the base. The area of the base is the magnitude of their cross product, V and W. Okay, that's the area of the base. That's the area of the parallelogram determined by those two vectors. So let's find the cross. I, J, K, V, 0, 3, 4, W, 0, 1, 1.
And base is equal to the area of a parallelogram, right?
That is correct. That's the area of this parallelogram down here. Okay? So, the cross is equal to, and what you do, you cross this out and this out, you have 3 minus 4. And then you cross this out and you cross this out. You'll have 0 minus 0. And it's the middle, so you have to take its opposite, but it's a 0, so we don't care. And then you have this and this crossed out for the k component, and that's 0 minus 0 again. Okay? So, V cross W is the vector negative 1, 0, 0. The magnitude of V cross W is equal to 1. Okay? That's the area of that parallelogram on the base. That's equal to 1 square unit. It's kind of interesting. Now, there are two ways to find the height. One way to find the height, and the more intelligent way, it seems to me, is to find the volume first. We have a formula for volume. The volume of a parallelepiped is the triple scalar product. Once we know the volume and we know the area of the base, guess what? We know the area of the base, we know the volume, we can solve for the height by taking the volume divided by the base. And that works. Yes?
And the other way is the projection of U onto, like,
The cross product.
W. Yeah. Okay.
Yes. And that's exactly right. That's the second way.
Can you show both ways?
We can show both ways. Let's do both ways. First way. First way, I'm going to calculate the volume first. Volume is equal to the absolute value of U dot V cross W. Okay? The absolute value is necessary because it depends on how the order that you do V and W. If you did a W times V, you get the opposite of this, and this is giving us a negative here. So, but you get the absolute value will be the correct volume. So what do you have? U, which is 1, 2, 3, dot V cross W, take its absolute value, and we end up with a negative 1, which is 1. Wow, that's pretty cool. The volume of that parallelepiped is 1. Okay? That tells us the height is the volume divided by the base is 1 divided by the base, 1. The height is 1. That's the easiest way to find the height. Find the area of the base, find the volume, and divide to find the height. But there's another way. And this is what Dylan just said.
Oh, that's the absolute value of 1? Is that what you're...
Yes, that's an absolute value of -1.
Yeah, that makes sense now.
Okay, thanks.
At first I thought it was like 3 1s and couldn't quite figure it out.
Oh, yeah, that wouldn't make any sense.
Yeah, like binary code or something.
Yeah, that would.
That would be on the test, right?
Yeah. The other way is to do what Dylan just said. What you want to do is find the magnitude of the projection, okay, we want to take the cross product, and the height is the magnitude of the projection on this cross product, which is perpendicular. The height is perpendicular. So let's take this.
I don't want to imagine.
Yeah, take this here. This is V cross W. Well, we already have V cross W, so that's pretty good. Oh, actually, it goes the other way, but it's V cross W is -1, 0, 0. It'd actually be dropped down here, but that's all right. Okay. And what we want to do is take the projection of U on that cross product. Okay? This here is the height, right here. Okay? So by taking the magnitude of the projection of U on the cross, we get the height, which would be this perpendicular distance here. Okay? So let's do it. Let's do the magnitude of the projection of U on the cross. Well, how do you do the magnitude of the projection? It's their dot product over the magnitude of V cross W. It's not squared, though. The magnitude of the projection is this. When you find the projection, it's this times the unit vector, which gives you another one of these, which squares this. But the magnitude of the projection is just this. Okay? It's the dot product over the magnitude of the vector being projected upon. Okay? Here. The magnitude of the projection of U on V, let me just throw this in here, is the dot product magnitude of V. Okay? That's the magnitude of the projection. The actual projection of U on V is the dot product over the magnitude of V times the unit vector, which usually makes this squared times V. Whoa. Okay, sorry. Whoa. I'm probably losing something. No, I got it all. I think I have it all. Oh, the word record is in the way. Okay? Okay, so whoa, what the heck? Well, we have all the information. Yes?
I didn't mean to go back, but if you were to make it so that you got the full projection instead of the magnitude, would it end up giving you the same unit vector that you had for the cross product originally?
Yep.
Wow.
Yeah.
So yeah.
It all works. Yeah, let's see what happens here. Wow, we already have their dot product. Okay, the dot product is with U and V cross W is here. We already have that dot product. That dot product is equal to a -1. And again, we want to take an absolute value of this thing. The magnitude of the cross we already have is 1. That's this here, 1. And again, it would come out negative, but we have to make it an absolute value because the height's going to be positive. What is actually happening here, I must tell you, is that it goes this way, and the projection of this on this vector is still this over here, but it's going to be negative. But just take its absolute value. That's all you have to do. And that's equal to 1. Okay. So the height is equal to 1, whether you do it this way or this way. Either way, it's equal to 1. Okay? What's the better way? There's no question about that in my mind that this is the better way. Okay, the first way is the better way. So what you want to do is find the area of the base, the area of the parallelogram, by taking the magnitude of the cross, use the triple scalar product to find the volume of the parallel pipette, and then divide to find the height.
Why
Homer.
is it the better way?
What's that?
How come? Why is it, what makes it better?
It's faster, quicker. See,
Faster isn't always better.
well, not always, but we have this. We're repeating some of the stuff we've already done. You know what I mean?
Yeah.
I think that way's the first way's better, but it doesn't matter. Do whatever way you like.
I like the first one.
I
Yeah.
actually heard the turtle won against the hare in the race, so.
All right, there, all right.
So when we do the dot product in the first method, 1, 2, 3 times -1 equals 0.
Yeah.
We get is that 1? I'm just not sure what that
A
is.
-1. It's the absolute value of -1.
Oh, absolute value.
Yeah, I had that problem
okay.
too.
Wow, I thought it was just you, Teddy. I guess not. It's the absolute value of -1. Yeah, that's what it is. All right, any other questions? Whoa, Liam.
So if you had taken the cross product of W cross V in the first place, then it would have been positive.
Oh, yes, it would have been. Yes, it would have been. And it would have been a little bit nicer. But it comes out the same. Yes. But you don't know ahead of time. I guess, okay, I did V cross W. If I did a really accurate drawing, which I really didn't do, you get the cross by using the right-handed rule, but evidently my W and V are just in the other direction, so it ends up pointing down is what happened there. If you did an accurate diagram, you could have predicted it, but it doesn't really matter. You just take the absolute value anyways. Yes?
I got a question.
Go ahead.
Something from the homework.
Go ahead.
The following plane, 3x plus 6y plus 9z equals 9. And then they want you to find P, Q, R, vectors PQ and PR, and PQ cross PR.
Okay. Did we do this one?
Yeah.
Yeah, I think we did this one.
You did? Okay.
Yeah, but let me mention this. Let me just tell you what you have to do here. You have to find 3 points. It doesn't matter the points that you use. Let's take P, take 0, 0, and then 1. And let's take Q to be 0, 0 for X, 0 for Z, and solve for Y. Y would be 3/2. And let's take R. These are the 3 intercepts, okay? This is where the plane intersects the axes here. And let's take R to be Y and Z to be 0, X would be 3. Those are 3 points. It doesn't matter the 3 points you use. Then what you want to do is take PQ, take that vector, 0, 3/2, -1, and take PR, say, and take that vector, take 3, 0, -1, cross these, okay, do the cross. I'm not going to do it out though, but what you could do. And what else did they say to do here?
That's it, yeah.
Oh, and then do the cross product. And what's going to happen is, wait a second, we know the answer to this. What is their cross going to be?
1, 2, 3.
It's either one. It's some constant multiple of 3, 6, 9. Okay, it's a constant multiple of 3, 6, 9. Did it come out 1, 2, 3? It could have come out 1, 2, 3. It could have come out 3, 6, 9 as well.
Could it end up being 3, 6, 9?
Yes, it could come out 3, 6, 9. It could. It could. Actually, it come out to be like 3/2. It came out to be like -3/2, -3, -3, and -9/2, or something like that. But it's going to be a constant multiple of this 3, 6, 9, because that is the normal vector, reading it right off here. Yes?
So that cross product is orthogonal to the plane there?
Yes, it is.
Okay.
Absolutely is. Boy, nice. Orthogonal to the plane.
Look at him with his terminology. That's
That's good.
I know, it's crazy.
That was good, man. All right, some more. Yes, Kyle.
Can you explain in Mathematica how to combine the two
Yeah, I was actually
sine
gonna ask
equations?
What?
how to combine the two sine equations, the y equals sine x and then x equals sine y. How do you
Oh.
combine those into one graph?
Okay.
It was a Mathematica tutorial on 3D.
Oh, I thought we did. Didn't we look at this?
Well, yeah, we did this yesterday.
We did.
It's the same thing. Like, I just don't know how to combine them.
Okay, here's what you do. Here's what you do. Watch this. You got y equals sine x and x equals sine y. Those are your two plots, your three-dimensional graphs? Is that okay? So the first one here, you do P1 equals, you give it a name first, parametric plot, 3D, and you do T, sine T, U say, and you give it some geez, poor planning. What the? All right, anyhow, you give it some T values here. T go from negative pi to pi. U go from negative pi to pi, say. Okay, so that. Okay, this, and close up that. I think I'm okay there. Wait, what the heck? Where's my, parametric plot. T, sine T, U, and then T goes there, U goes there. Okay, that's P1. And then P2 is going to be a parametric plot. Okay. And this is going to be, we want X to be sine Y, so it would be sine T, T, U. Shoot. Oh, I closed this up too soon. Okay, hold on. I'm sorry. Curly brackets here. Open the square brackets from here. Curly brackets here. And then give T and U the same values that you had before.
Wait, is the sign supposed to be in the middle?
This sign is in the, no, first slot, right? Because X is sine Y. This sign is in the middle because this Y is sine X. Okay? This Y is sine X. This is X is sine Y. That'll give you the two. It'll flip those graphs around. And the U values, negative pi to pi. Okay, all right, I'm okay there.
Do you have to write the plot function after that? You have to do plot and then.
No. Once you do this, you do a show statement. And then it's show P1, P2. That's the combined part that you need right there. That puts both of those on the same, puts the two graphs together as one. It combines the two. Oh, you got it there? Go ahead, do it.
Yeah.
All right, good.
I'm sorry, typing, I'll show you.
Yeah, all right. There you go. Okay, so we have to get done before Kyle stops typing because it's all wrong. But no. Any other questions? Yes?
I had one that I needed to see the trace.
The trace. Go ahead. This is on the test, by the way. I think I told you that. Traces are on the test. I'm going to give you a surface, and I'm going to ask for traces. And what the traces are, the intersections of those surfaces with the coordinate planes, xy plane, xz plane, okay, yz plane. Go ahead.
It didn't ask for one per plane, but it just asked for the general shape of the graph. It was 4x squared minus y squared plus 4z equals 0.
Wait, so traces are equations of where planes intersect?
Yes, that's what a trace is, okay? What I would do here, okay, is I would solve for z, okay? I would put 4z equals negative 4x squared minus plus y squared, and I would put z equals opposite of x squared plus y squared over 4. What this will give you, and I'm going to ask you for traces, okay? I don't want you to have to try and draw this thing out or figure out what it looks like. Mathematica does that. This is a straightforward plot 3D. Mathematica will do that. I think you should at least be able to determine what the traces are, okay? And that's what I'm going to ask you for. So what are the traces here? Actually, you're probably better off going back to the beginning now. But this is what you should use. You could use either one. What's the xy trace? I'll tell you what, I'm going to go back to the beginning here. The xy trace, you let z equal 0. Oh, this is tricky. This one's tricky.
Yeah.
Watch this. This is very interesting. You let z equal 0. You get 4x squared minus y squared equals 0. Now that is not a hyperbola, because a hyperbola would be 4x squared minus y squared equals 1. It makes a difference, the fact that it's equal to 0. You've got 4x squared minus y squared equals 0. You got 4x squared equals y squared. Can someone tell me what the heck that is? What is it?
2x equals y.
So you're saying it's what, Dinesh? 2x equals y. What's that?
A line?
That's one line.
Yeah.
But is that what you got here?
No.
No. What do you have?
2 lines.
2 lines. That's exactly what you have. Why 2 lines? Because when you take the square root, you got to take plus or minus. So you should have y equals plus or minus 2x when you take the square root. You get 2 intersecting lines. That's what you have here, 2 intersecting lines. And it is amazing. What's the xz trace?
Is that a parabola?
It's a parabola. Why? Because you're letting y equals 0. Okay, if you solve this for z, knock out the 4, z is the opposite of x squared. That's a parabola. Z is not squared, x is concave down. And if you do the yz trace, by letting x equal 0, what are you going to get there? Same thing, a parabola again. Okay, another parabola. So you've got 2 parabolas, okay, and 2 intersecting lines is what you have. And like I said, you do that in Mathematica, and you'll be able to see it. That's exactly what you have. I'm looking for the traces here, but Mathematica should be doing the drawing, in my opinion. Go ahead.
What's the XY say? Does XY trace say on the record?
What does it say?
No, is the record blocking it? So.
Oh.
You don't write anything. Okay, no.
Oh, I didn't write anything. Oh. It says nothing. Okay. All right. What else you got? Anything at all? What is that? Half a question, Adrian? Is that what that is? That's half a question. That's a whole question? Half a, no question. Okay. Go ahead.
Put more on like.
Village people, right?
Yep.
Village people. All right, go ahead.
Can you do spherical and some cylindrical coordinates?
Well, here's what you're going to be given. You're going to be given coordinates in rectangular, and I'm going to ask for various things. All right, so given.
Are we have to do any like equation transformation?
No.
Okay.
No. I'm going to give you rectangular coordinates. I did one the other day. What did I do? 1, 2, 3 or something? Probably. I should change it up to something else. All right. 2, 3, 4. How about 1, 1, 1? Let's do 1, 1, 1. This is in rectangular. 2, 3, 4 would have been good too. All right. Okay. This is 1, 1, 1 in rectangular. Okay, so you got 1, 1, 1, say. That's rectangular. Okay. I'm going to ask for things like theta in cylindrical, or r in cylindrical, as far as that goes. I am going to ask for rho in spherical. I know I wouldn't ask you for phi. Phi is crazy. You could do it by completing a right triangle and solving for it, but I know I wouldn't ask you that. These are the typical things I would ask you for. So let's do them. What's theta?
Pi over 4.
Pi over 4 is correct. Wow, good deal. Wow. All right, nice. It's inverse tangent of 1, which is pi over 4. I didn't think anybody would actually solve for it, and you kind of surprised me there. All right, what's r equal to? Square root of 2. Very nice. And what's rho equal to? What is it? Square root of 3. Very nice. because it's equal to the square root of 1 squared plus 1 squared plus 1 squared. Okay? That's the kind of thing I'm going to be asking you to do. Okay? All right, what else you guys got? Anything else at all?
Yeah, just gonna write that.
Oh.
Also, rho is just the square root of all the coordinates summed up in rectangular. Square.
Squared. You got to square, yeah. Sum of the squares of the rectangular coordinates.
Pythagorean theorem extended.
It's what it is a Pythagorean theorem. Exactly right. Because rho, being this distance in this right triangle, is this squared plus this squared. But what is this squared but this squared plus this squared? So it's this squared plus this squared plus this squared. And then take the square root. Okay. Anything else at all? Anything? You all set?
I got one thing.
Whoa, one more. Go ahead.
Can you just do like given points in space, find the equation of a line?
Of course. Go ahead. You got one, or you want me to make them up?
To an extent.
Okay, here we go. We're going to be given some points in space. 2 points in space. Where do you want? The line through? Yeah, okay. That's what you said, right?
Yeah.
Here's 2 points in space. What we want to do is find the equation of the line in space through these 2 points. Okay? We need a direction vector, which is the vector PQ, which is 2 minus 1, 3 minus negative 1, 4 minus 0. That's our direction vector. We need a point. I'll tell you what, take either one, it doesn't matter. Okay? The equation of that line is x equals, I'll take point P, 1 plus 1 t. This 1 here is the coefficient of t. Y is equal to negative 1 plus 4t. Z is equal to 0 plus 4t. And you may protest, say, Burns, what happens if you use the other points? Well, you get something that looks different, but generates the same line, okay? So also acceptable would be x equals 2 plus t, and y equals 3 plus 4t, and z equals 4 plus 4t, okay? Those would be the same line. They look different, but they're the same line. T is 0, you get 1, negative 1, 0. When t is negative 2, you're going to get 0, negative 1, 0. You get the same points for different values of the parameter. Okay? But you get the same exact points. Those 2 lines are the same. Yes?
What about equation of a plane?
Equation of the plane, now you need a third point for the equation of a plane. If you had a third point in here, okay? Let's say 0, 0, 3. Okay, so those are 3 points. The equation of the plane, you're going to need 2 pieces of information. You need a normal vector, and you need a point. Well, we've got 3 points. You've got plenty of points here, but we need a normal vector. Where are we going to get a normal vector? We're going to get a normal vector by finding vector PQ, which would be 1, 4, 4. Oh, I already knew that. Wow, there it was. And then PR to get negative 2, negative 3, negative 1. That is QR. You're absolutely right. Wow. Good call there. That is QR. And now what we're going to do for our normal is cross these guys. Our normal is PQ cross QR. So we're going to cross these. And we're going to get our normal vector. Cross this out, cross this out. We get negative 4 minus negative 12. That's negative 4 plus 12. That's 8. Cross this out, cross this out. We get negative 1 minus negative 8. -1 plus 8, 7, but we have to take its opposite for the middle one. I hope, I think that's okay. Is it right, Anthony? Okay. And then cross this out, we get -3 minus -8 is -3 plus 8 is 5. That's my normal vector. So, we have everything we need. We need a normal vector and a point. I'll take this point. This point looks easiest. So what is our equation of the plane? It's 8 times x minus 0 plus a -7 times y minus 0 plus 5 times z minus 3 equals 0. So we would get 8x minus 7y plus 5z minus 15 equals 0, or equals 15. It really wouldn't matter. And I'm not sure how I have it on the test. But
Where's the z minus 3 coming from?
the z minus 3 comes from the 5 coefficient, comes from here. The z minus 3 comes from the z coordinate of this point R that I'm using. Now, and you can verify this. Take the point P. Is that on this plane? Well, let's check it out. When x is 1 and y is -1 and z is 0, do we get 0? Let's see. 1 here gives us an 8. A -1 in here gives us 7. That's 15. A 0 here gives us 0. 15 minus 15 is 0. It works. And 2, 3, 4 will also work. 16 minus 21, -5. Plus 20 is 15, minus 15 is indeed 0. It works. Yes?
So, two things. One, you used point R when you were doing your x minus. Did you have to use point R because that's where you were crossing, or could you have used
No,
those three?
any point. Any point would work.
Where did the -15 come from again?
Yeah.
Huh?
The
This -15?
Yeah.
5 times the -3.
Oh, okay.
I multiplied it through. Use any point you want. 2, 3, 4, guess what? Same thing. It will come out to be the same. It's magic. Okay, nobody knows how it works. It just works. All right, what else we got?
Wait, so just to be clear, that's the equation of a plane, and then the first one was the equation of a line?
Correcto.
Alright.
This is the equation of a line. This is the equation of a plane. Got it, yes. This is the equation of a line, too.
So you can pick any set of points, put them in, and then work.
Yeah. And it's amazing.
You put in like a 0,
You can do whatever you want. Which one are you talking about, the line or the plane?
either one.
I don't care. But you got to be careful. I mean, 0, 0, 0 is not on this line.
Okay.
Okay? You got to pick a point that's on the line. And I had these 2 points to choose. That's why I used, here's one, this, 1, -1, 0 is this one. It's 1, -1, 0 plus 4t. And the 2, 3, 4 was this one. I mean, it's got to be a point on the line. Okay? And the same with the plane. You've got to take a point on the plane. But any point on the plane works. Every point on the plane works. All right, what else? Okay, finally, tomorrow, the test, finally. Jeez, it seemed like we...
I think we
Might
gotta
as well
push.
just throw it
I think we
out.
gotta push it back, Burns. I think I'm ready. I could use another couple months of review.
Oh, man, I think we've done every homework problem there was. I think we're